This is what a basic electrical network look like. It contains active elements such as current and voltage source, passive elements such as resistors, capacitors, inductors, and switches. To understand complex network such as power system, which contains generator, transformer, transmission line, load, and a ton of different equipments, and perform analysis such as steady state analysis and transient analysis, it's very important to understand electrical networks. Side notes: in steady state analysis, we find current, voltage across power for each element, keeping in mind that there is no sudden disturbances. While transient analysis deals with how electrical elements behave when they are subjected to a sudden change in the network, such as what happens when the switch position suddenly changes. Let us make a quick note of the prerequisites for the subject, which will be very handy to learn electrical networks. Okay, let's start with electrical elements. Electrical elements can be classified into many different ways. One way to classify electrical networks is whether it's an active element or passive element. Active elements are those elements which supply or generate electrical power. For example, battery, generator, voltage source, and current source. Passive elements are those which absorbs electrical power and can convert it into heat as it happens in resistor, or it can store energy in electromagnetic form or electrostatic form, which happens in the case of inductors and capacitors respectively. Side notes: depending on the placement of the element and condition of the circuit, an active element can sometimes behave as passive element. That is, instead of supplying power, these elements absorbs power. This happens when you charge your cell phone or when you charge your inverter battery. The combination of these active and passive elements connected in any manner is called as electrical network. Another way to classify elements is whether it's a bilateral or unilateral element. Consider a resistor R connected to a voltage source V. We observe a current I flowing from positive potential to the negative potential. There is a voltage drop V across the resistor, and there is a power loss P, which is equals to I square R, or it can also be equals to V into I. Now, if the voltage polarity changes, then we find that the current is flowing in the opposite direction, but its magnitude remains the same, and the voltage drop and power loss is also same. This happens because resistance offered by the resistor is independent of current direction. These elements are known as bilateral elements. Now consider a diode. During forward bias condition, the resistance offered by the diode is very negligible, but in reverse bias condition, the resistance offered by the same diode almost moves to infinity. This means that the current can only flow in one direction in this type of components. These trends are known as unilateral element. Moving on to linear and nonlinear system. To understand the concept, we first need to understand what is a system. A system is a collection of objects that is under study, to which we give an input u of t and get an output y of t. This is typically known as dynamic system, in a sense that it essentially deals with variables like input and output that are functions of time. Mathematically, we can define a system as a mapping S from u of t to y of t. That is, y of t equals to S of u of t. Now, to define a system to be linear, it has to obey two properties: adhesive property and homogeneity. To understand this, consider a system S with input u1 of t and output y1 of t, and to the same system another input u2 of t and output y2 of t. Now the question is, if we sum these two arbitrary input, that is u1 of t plus u2 of t, whether the output is also the sum of two individual output, that is y1 of t plus y2 of t. If the answer is yes, then the system is adhesive. Another property that needs to be satisfied is that if the input, which is an arbitrary scalar multiple of the input, let's say u1 of t, then the output y1 of t must also be a multiple of the same scalar. Here C is the scalar multiple which belongs to real number. This property is known as homogeneity. Coming over to linear electrical circuits, voltage current characteristic can be represented by a straight line passing through the origin. This means that the parameters does not change with voltage or current, and the circuit obeys homogeneity and adhesivity. In case of nonlinear circuits, the voltage current characteristic is not a straight line. This means parameter changes with voltage and current and does not obey homogeneity or adhesivity. Side note: in practical condition, most of the systems present are nonlinear in nature, but still we study linear systems because these systems are predictable. That is, we already know the response of the system when subjected to a few special inputs, such as impulse, step, ramp. This makes the system response to be predictable for any other input. Another reason to study linear system is that a nonlinear system can be linear for a small incremental change in time. Hello everyone, this is Arijit. Hope you like my video. The idea is to make quick notes on subjects related to electrical engineering such as electrical networks, control system, electrical machine, power system, power electronics, and renewable energy. I will also make quick notes on some multidisciplinary subjects such as engineering optimization, fuzzy logic and neural network, and some relevant software to work with. If you are interested, you can subscribe to my channel, and if you like this video, press the thumbs up button, and you can use the comment section as a discussion forum to interact with each other and with me as well. Again, thanks for watching my video. See you in the next video.